Good morning, sir.
Yes, Colofelo, good morning. Let me check who are there. Felicia, good morning. Laborang, good morning. Lucia, again,
Good morning, sir.
good morning. Maropeng, Frida, Matome, Dineo, Susan, Musibudi, Chwene, Rosaline, Puseletso, Portia, Mary, Tato, Blessing, okay, Blessing, Clement, coming. Just give me 1 minute. I'll come back to you. Sorry for that. There were people from cabling. They were here, and they were seeking to check the cables. But I told them to come later. That's why I had a problem with network. It's because of cabling. I was greeting everyone in class, trying to greet as much as I can. Gift Mpo, Gaurelo, Komocho, Gaurelo, Kolofelo, Stephen, Leslie, Samuel, Moses, Ndewo, yeah. So I was just saying good morning, ladies and gentlemen. Are you still there?
Yes, we are here, sir.
Oh yes. Do you see my face? I think I'm visible. I'm in the office wearing spectacles. I hope you can see me. I hope you can see me. I'm in class. Yes, okay. Then that is my name there, Laboro RJ. Or you can call me sir if you can't pronounce my surname. Then you can just call me sir. That is very important. That is very important. My office number is 2027 Mets Building, and my office telephone number that is 015-268-3587. Why I decided to put all the numbers there is because some of you are off camp, some of you are at home right now, but that is my number. That is my number, my office number. And also on the issue of the class, I want us to talk about the issue of the class. Yesterday, the class of yesterday was postponed to today, 3 o'clock. Then that means at 3 o'clock we'll be having another class, and we'll work out the tutorials. Don't worry, we'll work out the tutorials. I believe next week, after doing what we are going to do today. If we don't finish today, that means on Friday there will be a class just to complete everything, just to complete everything. Okay, everything. Any question, ladies and gentlemen, before I start? Before I start with the randomized block design, I want to thank Mr. Maluleka for doing some introduction on the issue of the block randomized block design, so that today we can fly. Any question, ladies and gentlemen, before we start?
Sir,
Mo, yes. Tuto, yes.
today can you please repeat the introduction?
Yeah, that is what I'm going to do, a review on the introduction on the randomized block design. I'm just going to do just a review on the block design, on the random block design. Yes. Okay, then let's start. Let me check whether the things are they writing or not. Okay. Can I let me switch off the video because it might be slow. Yes, as you said, we must do some background on the random variable, on the randomized block design. On the randomized block design, let me do this. Yes, let's take this. I will use this as a cover up of what the introduction is all about, because advantages and disadvantages, they give us the introduction. Now, with the why are we doing a randomized block design? This randomized block design, as they are saying, can accommodate the treatment and also the replications in any of the blocks. Let me talk about the issue of the blocks. You did what we call the CRD, where it was without blocks. You were only having one factor, which it was, for an example, you did an example. Let's say you have student performance, only performance, or student performance, or performance, test performance. Let's call it test performance. You had only test performance, and on that test performance, there were what we call replication on test number 1, test number 2, and test number 3. But there is something that we can use to test, or a factor that we can use to find the test performance. And what is that factor? Mr. Malulaga told you about. I'm using this example because Mr. Malulaga used this example. Then you have test performance. There is one factor which you can use, which is student. The student becomes the factor that determines the test performance, because you can't find test performance without students writing the test. And above all, also the performance of the test can be on different levels of students. And there is one thing that we call nonsense factors. These are factors which are they measure the results. They measure the results. The nonsense factors, they measure the results of what? Of test one performance. Now, with us right now, our nuisance factor is going to be only one factor. That factor, we call it student. That factor, we call it student, to determine the performance or the test performance. We are going to use the students to test the test performance. Now, there are other nuisance factors, but we are going to do them when we come to chapter 4, whereby the Latin square, it will help us also to factor in other factors that may contribute towards student performance or test performance. For an example, before even I can go there, for you to get a better marks, a single student, let's take a single student, a single test, a test one, a 3 student, because we said student becomes now our factor, our main factor to determine the test one performance. Now, there is student 1, student 2, and student 3. Now is a student. Now, when we go to Latin square, we will check because there are many factors there. There are factors that can affect the first student. For an example, one student is staying in Mountain Town. The other one is staying in the campus. The other one is staying in town. Now, we talk about environment. Environment has affected those students. Now, those will do when we come to the least square. But in essence, the randomized block design, we are using it whenever we are having two factors. Now, the advantage number 2, if block is effective, what do we mean by block effective? It means that yes, block 1, block 2, block 3 until block J, and the other one says at least one differ. Now, when we are saying blocking is effective, is whenever this occurs. It means on our example, that means that factor, it was a fact. I will show you the sketch. The difference between the CRB and the RBD. On that essence, if you find that H1 is one of the betas are different, then that means blocking is effective. That means that factor, blocking just means factor or variable that was included. Remember, is it there? Yes, remember under CRD, you were only having this. But now under the RBD, you are including another factor. I just want to show you something. you are including another factor that might contribute towards the response variable. Another factor that might contribute towards a response variable. And if that factor here, when we are going to test here, if we find it to be that, that means the RBD is effective. Then the other one, let me explain these advantages. Then I will come to you. Maybe I will answer you when. Then the test statistic or the statistical analysis is a two-way ANOVA. Now, because it's having what we call the block and the treatment. Yeah, you can ask, and also under the RBD, you will get the answers. Yes, you can ask.
Oh, sir, I thought maybe you are on another slide. So
No. I'm still on. Now you have disturbed me. I'm on that slide. I just want to explain. Okay, for those who don't know me, I'm trying to explain. I might take some time on one slide for a period of time, but afterwards, then I will fly, because I want the introduction or the foundation to be concrete. Then after, if the foundation is concrete, then we can fly. I'm still on slide number 2. Still on slide number 2. Yes, I wanted to explain this. Yes, before two-way ANOVA. Now, when we are saying two-way ANOVA, under the CRD, you are doing one-way ANOVA. One way. It means you are only having what we call the treatment. You are only having the treatment. But here, because it's a two-way ANOVA, now you are having the treatment and the other factor or a variable we call this block, and this we call treatment. Yes. Now there are also disadvantages, but some of the disadvantages will be catered in another part, which is not to, we are not going to do today. Since the experimental unit within a block be of the same kind, the design is best suited for relative small number of treatment. It means it's good whenever you have small number of treatment than having multitude of treatment. A statistical analysis, which is we have seen, which is the ANOVA of the experiment, is complicated. ANOVA is having complication in terms of, I will show you why they're saying the complication. If some missing observations within blocks, if they are let me do this, if they are missing values. For an example, I want to write something there. Wait a bit. Yes. Then, if you are having this, I don't know what's happening, but something is. If you are having something like this, and you are having a number here, and you are having a number here, let's say this is student 1, student 2, and student 3, and this side you are having test 1, test 2, and test 3. Now the other student did not write test test 3. Now you are having a missing value here. Then it becomes a problem when we do the ANOVA. But don't worry, that is what we call whenever we have unbalanced data set, we try to estimate. Don't worry, that one also will be the degree of freedom of experimental error are lost to blocking. I'll show you this one. The experimental errors are lost through blocking. I'll show you that. Now, let's come here. Somebody was asking me about just give a slate of black background. Blocking allows us to remove the variation due to the different amount the blocks from what for experimental error. Let me show you what we talk about. This is the sketch that I was talking about. This is the sketch that I was talking about. Let me maximize the sketch. Let me maximize the sketch. Now, when you were with Mr. Malulek, you did the first part, which is this part. You did this part, only this part. Then you were only having the treatment. You were only having the treatment. I just want to do something. Just give me 1 minute. Okay. Okay, I know something is wrong, but it's fine. I'll use then with the CRD, which you used here, you only had one variable, which is the treatment, and you had the treatment and the sum of errors. And this it says, listen to this. It says the blocks allows to remove the variation to the different amount blocks from experimental error. From this, now look at this. From this error, now what do we have? We remove two things, which is the blocks and also what? The errors. That means, what are we saying when we are removing? We are saying there might be another factor. There might be another factor that contributes towards the response variable. Any question before that? Before I come to example? Any question, ladies and gentlemen? Any question? Any question?
No question,
If there is
sir.
no question, let's continue. Let's continue. Then this is an example. It says a study was taken. Is there in your notes, in your study guide? I just took it from the study guide. A study was undertaken to compare the starting salaries of bachelor's degree candidates at the University of Limpopo from the School of Computational and Mathematical Sciences. Let me explain why we said the School of Computational and Mathematical Sciences. Because of the following. for the academic years 2004 and 2005, 2005 to 2006, and 2006 to 2007. That is the financial year. Now, during that time, during those years, some of you were still young. Maybe some of you were 3 months or 5 months, or maybe somewhere there. The school was called the Computational and Mathematical Sciences. We must just give you the history, so that you may know the history. Now, then, full stop. 3 students from mathematics, 3 students from statistics, 3 students from computer science were available for the experiment. They were available for the experiment. Now, the question that we must ask ourselves, if you read that statement, if you're having a phone, you can take a picture, because I'm going to another slide of questions. If you're having a phone, just take a picture for this example, then I will go to another slide. Are you done taking a picture? Done. Okay, let's go. Now, from that question which you have, what are the experimental units in the proposed experiment? The proposed, what are the experimental unit? Yes, you can ask.
Students.
Oh yeah. Why are you saying students? What I'm saying, yeah. I'm not saying I agree. I'm saying yeah because I love the way you said it with confidence. Continue. Continue.
Because they're being tested.
Oh yeah. Yes. Another one. Continue. Because there is more. I wanted you to say yes. Is correct. Is correct. 100% is correct. The experiment is applied on the students. Yes, is applied on the students. Yes, you are right. Is also right. Is the students. The students are our experimental unit. It means then what will be our treatment then? Then what will be our treatment? Okay, let me put it this way. This thing does not want to write. I just want to write. I was writing before, but I don't know why right now things have changed. I don't know. Don't know what happened. I don't know what happened. I don't know what happened. Things are not going well. Now, there is a background there. Yes. Yeah, I got it. Cancel the background. The students. Experimental unit. A student. Why? Because this experiment of what? Or want to find the starting salaries at the university for those who did bachelor's degree in our school, their starting salary. That is what we want to find out. The salary, the starting salary of the students, which is experimental unit. What I wanted to say was the starting salaries, to compare the starting salaries. That is what we are going to do. Using what? Using how many years? 3 years. Using 3 years. Now, let's go to the next question. Which design? Which design are the CRD? Now you see now. Oriel, you see me. I'm enjoying. You are giving answers before. But let's continue. Which design? Yes. Give me a reason. Tukza, give me a reason. Why are you saying is a RBD? Why are you saying is an RBD? RBD. Now, they are correct to say that is RBD. I'll explain. We are having two factors. We are having two factors. This is the factor which we are going to take. The financial year, the years, the academic years. That is what we are going to do. And another factor is we can call them modules, as he said, modules or curriculum or what? Computer science, stats, and mathematics. They fall under curriculum or module or course. Yes. Tutor.
So, sir, what are the treatments here?
Yes, that is the question. What is the treatment, ladies and gentlemen? What are the treatment? Because I asked that question, but I managed to answer you. What is the treatment?
Academic years.
Academic years. Another one.
Modules.
Modules. Remember, ladies and gentlemen. Remember, the treatment and the blocks are different. The treatment, the blocks, they tell us about what we want to test, isn't it? There's a factor there that needs to be considered, whereby we are saying the treatment, like for example, let me write, because this now is writing. Now this is the starting salary, which is 004, 005, 006. Now these are the blocks. And when you were doing example with Mr. Maluleg, you said this is a student. You said students are blocks. Now, there is a factor that indeed can help us to determine that why people are getting this starting salary. And we said, because we are taking students from this school, we can take a student. Remember, it's a student. Student 1 will be from maths. Student 2 will be from stat. Student 3 will be from computer science. Now, these are students. It means maths, statistics, and computer science. These are students who are doing that module. These are students who are doing that module. But the treatment becomes what we call the starting salary. of that academic year. Starting salary of that academic year. It's not the student. Do you understand, ladies and gentlemen? I tried to explain it. Do you understand?
Yes, sir.
Yes, sir.
Oh yes. Tabiso.
What is the response?
There is what the response variable.
The response variables.
The yi. That I'll come to that because right now I'm explaining because at the end this is going to be what we call the starting salary. The mean plus the treatment plus the BJ. This one is this yes, and this one is this this 3 students of mathematics, statistics, and computer science. That is how it is. Now I tried to explain that one. Any question before we go to the last one? Even the last one will answer your question. In case of your answer to 2 is RBD, what is the blocking factor? Manyama? Manyama? Anyone? When I'm saying Manyama, I'm not saying him personally. I'm just saying what is the blocking factor? What is the blocking factor? What it is that can explain the salaries? What it is that can explain the
The
salaries?
number of years. The number of years and modules.
What it is that can explain the, remember, block. We said student. Remember, we said block. The block there is students. Do you agree?
Yes.
Ladies and gentlemen, that is what you did with Mr. Malulega when you were using test performance. You remember, you had students here, and students become your block. That means a factor. Let me go back a little bit, or maybe I was rushing. Yes, when I was explaining number 1, this it can be used to accommodate any number of treatment. It can accommodate any number of treatment, replication in any of, because replication, you did replication with Mr. Maluleka when you were doing the CRD. Now, the block is the factor there. The fact, what are we using is a factor. Mathodi, now let's give the analysis. Ladies and gentlemen, today or right now I will only deal with theory, the theory part. Then we'll do an example, maybe at around throat lock. We'll do example in throat lock. Just bear with me. Let me give you this foundation, which is very important, so that at throat lock, when we do an example, so that it may be simple to do. Yes, a randomized block design can be used to compare the T, which is the treatment means, when additional source of variability block is presented. Maybe I was supposed to start there. This can compare, which is the T, the treatment means. You remember when you were doing with Mr. Malulega, you had the first treatment. You must compare the mean. Let's say the mean. You were doing one way, ANOVA. Let me do this. You are saying mean 1 is the same as mean 2, is the same as mean 3, is the same as, and so forth and so forth and so forth. And we said we are using the ANOVA because we don't concentrate only on 2 means. We are having more than 2 means. That's why we are using the ANOVA. We are using ANOVA because we are having more than 2 means. But if we have 2 means, we'll use that one that we normally use at first year. Then the H1, at least 1 is different. At least 1 different. Now, when we are this one, we compare the treatment means when additional source of variability, which is the block or the variable, is present. A randomized block design, experimental design for comparing T, that is what we are going to do. Treatment in B, that is what we are going to do. Treatment are randomly assigned to experimental unit. This treatment are being assigned to experimental unit. This treatment, the treatment under the salaries, are randomly assigned to the experimental unit, are assigned to what? To student. That means this student, salary 1, student in mathematics, salary 2, and so forth. Within the block, that means that student, sorry, please somebody, if you write and I write, it's going to be a problem. If you write and I write, it's going to be a problem. Let me do this. The treatment are randomly assigned to the unit. Now is a starting salary of 2004. Now the experimental unit, the student. Under the student, you are having, we are saying there might be another factor that is within the student that affects the salaries. Maybe a person did computer science. Maybe the person did mathematics. Maybe the person did applied mathematics. Maybe the person did, and so forth and so forth and so forth. Within each treatment, within this treatment, within that treatment. It means under treatment 1, let me just write it. Under treatment 1, under treatment 1, Remember, ladies and gentlemen, I'm just doing the theory. I'm explaining the theory. Don't say, why are you writing numbers? No, I'm explaining the theory using that example. 2004 to 2005. This is a treatment, first treatment, whereby we are having experimental unit. I want to show you something. These are students. But we are blocking student using experimental unit within a block, within stats. This is statistics. This is mathematics. This is computer science. We are saying this curriculum or these modules can explain this. The salary, as the man was asking, the salaries of 2004 to 2005 can explain this. Maybe not only the student, but there is a very component, another component, a variable, we call it a block, that can explain this. And this becomes our first treatment. And we can do that on each and everything. As it says, within each treatment, appearing exactly once in every block. This is 2004 to 2005. It's here. 2004 to 2005 is also here in mathematics. 2004 2005 is also here in computer science. Any question, ladies and gentlemen? I was explaining the analysis. Any question, ladies and gentlemen? Any question? Okay, then we are having, without any question, we are having what we call the general model. The general model. Since we are having now, we have introduced the blocks. Now, our model ought to change. Remember, you had the CRD, which the model was this, plus the treatment, plus the errors. It was like that. But since right now, since we are including another variable called blocks, now our model is going to be given by this. The model is going to be given by that. And we know very well that we have both what we call the fixed effect model, where we are testing. Okay, I will come to it. Where we are testing the two, the first one, the treatment, and also the blocks. And also when we test the variation or the variance when we come to the random effect. Ladies and gentlemen, do you know what I have written here? Do you agree that in CRD it was this?
Yes, we agree.
Oh yeah, yes. No, ladies and gentlemen, are you there? I heard
Yes,
that
yes, yes.
you are sometimes getting 10 minutes break. Um, I will also use that that model for 10 minutes breaks. I don't know whether do we have the timekeeper here in class. Timekeeper. Okay. Yeah, you let me know, timekeeper, because I don't know you. You will let me know about that 10 minutes break. Now, Mabunda. Yeah, Baba Gerald Mabunda. Is that you? Okay. Let us see. Let's see. Now, yeah. Thank you very much. Thank you very much. Then now we are having this the mu, where this mu is denoted by the population mean. This is the population mean. This is our treatment, and this is our blocks. This is our errors. This is our starting salary. Starting salary. Starting salary, which is this. This one will be our year or academic year. And this blocks will be our module. Our modules, yeah, in our modules, our courses, 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 or curriculum, yeah, curriculum. Now, this is our errors, random errors. This is our random errors, and these random errors are associated with the response on the treatment. They are response on what? On the treatment. On the treatment, the same as blocks, because of the treatment, because of the treatment, because of the treatment, because of even the errors is because of what? Of the treatment. And on response J and blocks, which are assumed to be independent. That means they don't depend on each other. They don't depend on each other, and they are normally distributed. That means this is like this. They are normally distributed with zero and variance. That denoted with zero and variance. Ladies and gentlemen, do you see the formula? Do you understand the formula? Any question on the model? Any question on the model? Ladies and gentlemen, are you there? Please, if you don't, if you cannot speak, just write on the chat, because personally I believe in interaction. Interaction. Let's interact. Let's interact. Now, this is what I'm talking about. What I'm explaining here. Let me maximize this. You'll let me know if you don't see. Let me do this a little bit. Yes, this is now. These are the blocks. I wanted to do this. These are the blocks. These are the blocks. And these are the treatments. These are the treatments. These are the blocks. Now, we look at this is treatment number 1. I'm just going to use this example. This one. Treatment number 1. Under treatment number 1, the only thing that does not change here is the first part. Is the first part. The second part changes. The second part changes. If you look at it, the second part changes, but the first part does not change. That is Y11. When you go to block number 2, is Y12. When you go to block number 3, is Y13. The only thing that does not change here is the first one. Do you see? The first one. because you are on what? On the first treatment. And also you have the total. The total is given by this. The Y 1 dot. I heard that you are using the signs, the signs of the treatment, which is a wonderful thing of this as the treatment, and we'll use this as blocks. This will be blocks. This will be what? Treatment. Will be treatment. Will be treatment. Will be treatment. Now, and also when you come to blocks, if you come to blocks, when you look at it, what does not change here is the second part. The second part, it does not change. Then if the second here is Y or under blocks, Y11, Y21, YT1. What does not change is this one. The second part does not change. Then it will be Y dot. This dot is the one that changes. The one that changes. Okay. Then now we are having the total. The total will be this, and the mean will be that. The mean will be the sum of all this, which is the total, divided by the total number, which is the t. Which is the t. Any question, ladies and gentlemen, on how to find the total and the mean of both the treatment and the blocks? Any question?
Sir,
Yes.
you are saying we divide the total by t.
Yes.
Which t?
We divide this. Sorry. You see this one?
Yeah.
Yes. That means you have to add everything here. Maybe the last one is t. Let's say, let me put it like this. Let me put this way. Let me put this way. Let's say when I'm saying t, I mean if t is the last number, let's say is 15. That means your 15 number, you have to divide it by 15, isn't it?
Oh, okay. I thought maybe treatment.
No. Sorry, I will use another term. Sorry, let me use another term. Let me say n, because the first n, isn't it? The first of block. Yes, the n of block 1. Yes. Let me use
Yeah.
that. Yes. Thank you very much. Thank you very much. The n of block 1. Then you say the sum of block 1 divided by the n, the total number of observations that are in block 1. That is what I'm talking about when I'm saying n. People will say n. Now, oh, you're talking about n on the treatment. No, I'm talking about the total number of observations that are in block 1. Any question, ladies and gentlemen?
Sir,
Yes. Who's talking?
okay,
How can?
with Manyama. Yes.
Oh, Manyama, yes.
Yeah, sir. What you are saying now is that on the treatment, when you want to find the mean of the first treatment, you are going to divide by the number of blocks you have. Then when you want
No. Okay, continue.
I am saying, or for example, we want
Yeah,
to
oh yeah.
we want to find,
Manyama.
we want to find the mean. We want to find the mean of treatment 1.
Yes, this one.
When
Let
we
me
want,
point it. Let me point it. This one.
yes, sir.
Yes.
If we want to find the mean of it under
Yes.
these blocks, it means we are going to divide by B.
If you want to find the mean, if you want to find this one, let's find, for an example. For example, let me do it. That's this example. Let me just because you said example. Me also, I do example. Let me do this. Let's talk about something which is you have. This is treatment number 1. Let me call it. Mr. Manulaga was talking about method of teaching. Some teaching them in OCH, what, and let me say 2. These are treatment. Let's say this is student 1, student 2, student 3. These are the tests that which they got. These are the treatment. These are the treatment. These are the blocks. Then here you're having 1. Here you're having 5. These are the quizzes. This is 6. You're saying if you want to find the mean, let's continue. If you want to find the mean
If I want
of
to,
this, you are saying the mean, isn't it, of this one?
yes, sir.
Yes. Then what will be the mean for the treatment 1? Ladies and gentlemen, what will be the mean for method 1? The mean for method 1. Ladies and gentlemen, please, I said let's engage. Let's talk.
4.
Let's talk.
4.
Let's talk. Okay. Because now I'm also going and doing a, okay, because I want us to, yes, this is the mean. Then what will be the total? First, let's start with the total. What will be the total for the treatment 1?
12.
Will be 12. Then what will be the mean for treatment 1?
4.
That will be 4. How did you get 4, ladies and gentlemen? How did you get 4?
I divided by the blocks, which is the number of tests which we have. Is 3 tests. We divide by that number of the.
Oh yeah, Manyama. I understand how you magate or you navigate the situation. Okay, okay. But the issue is the total number of observations. The total numbers of observations that are in treatment number 1. There are how many observations? There are 1, 2, 3 under treatment number 1. There are how many observations? There are 1, 2, 3 in treatment number 1. Do you say, Manyama? You are also right.
See,
Yes,
sir.
now let's come. Yes, you are also right. There are many ways to fry a dog. Then let's come to blocks. What will be the total for block for test 1? T1 will be 8. Then what will be the mean? Somebody, can you answer Posinati? How do we find the mean? How did we find 4?
For us to find the mean there, we have to check the number of per treatment. We have to now check the number of observations per treatment, then take the number of those observation, divide the total, then you get the mean.
Manyama,
Uh,
can you repeat?
We check on the treatment. Looking at the
Yes.
treatment which we are speaking of, we check the number of observations per treatment, take the number of,
Yes.
then we, from looking at the treatments, observations, taking the sum, we divide by the number of those observations per treatment, we get the mean.
Yeah, no, yes, answered. Posinati, are you fine?
sir.
Ngosi.
Hello, sir.
Oh, it's not you. It's Sacrament.
Yeah, can you hear me?
I can hear you very well, loud and clear.
All right. I want to understand something here. So,
Yes.
given this table, I think it's a matrix, right? It's a matrix table, like a 2D array. So,
Yes.
in other ways, to get the mean for treatment one, it means you're going
Yes.
to add whatever is in row one,
Yes.
the
Yes.
observation,
Yes.
those observation in row one, and we divide by the
Yes.
number of blocks they have.
100%. That's why Manyama I said he can fry a dog in another way. That is how it is. Yes.
Oh, so in order for us to get the mean for the treatment there, that means you're going to deal with columns there.
For
What?
what? No, okay. Let me put it this way. Sometimes they can. Yeah. Let me do. Yeah. Let me do this way, so that because I know uh, this way. Sometimes let me do this. Sometimes we can put blocks here and treatment there. Do you see?
Yes.
Yes, but the procedure is the same. Meaning, if it's like this one will be treatment, isn't it?
Yes.
Yes, and this ones will be blocks, isn't it?
Yes.
Yes, that is what I'm saying. They can change. They can change.
All right, I understand, sir.
Okay. Let's go to, because now I'm explaining the formulas. Now let's come here. The formula. I know you used you did not use this formula. You used another formula, which I will put. You used this formula, whereby this are just the values. I will just use that example. This is method one. This is test one. This is just y11. Tabiso?
So I was asking maybe about the break since the timekeeper is not available here. What
Oh,
are we
oh,
doing
it's
in
time.
the break?
Oh no,
Yeah,
that's
let's
why I said.
proceed.
That's why I said you must let me know, because I don't know the person and I did not see any writings. But let's take a break for 10 minutes, then we'll come back at 27. Let's let's take a break. We'll come back at 27. Thank you very much. Ladies and gentlemen, I hope you are sitting down, and we are about to continue. We are about to continue. As we said, right now we are going to do all this theory part, and then in the afternoon, whatever we did today, whatever we did right now, we have to calculate it. In the afternoon, we are going to calculate whatever we did now. Now, the first one is the SS total that we have to do. Now, the SS total as SST, the SST, which is the treatment, the blocks, and the errors. The sum of squares of total is having the T, which is this T is for the treatment, it's not for total. We distinguish them by SSTO, which is total, where this SST is for treatment. Remember that, ladies and gentlemen. Then this one's, is whenever you want to find the treatment, this is the formula. I know that you are having another formula which is there. I'm going to project it. And also, if you want to find the blocks, this is the formula where this ij denotes where this is mean. Sorry, this is the mean. It's not visible. Let me just put something. This is the mean. This is the mean. Y bar. Yes. Then this is the T. This is for treatment. Whenever you calculate the blocks, if you're going to calculate the blocks, you must multiply it with what? With treatment. If you're going to calculate the treatment, you must multiply it with what? With blocks. With blocks. Then Datamanyama.
I have a question here. The question goes this way. I want to understand here. Since this formula of partitioning the sum of squares, now we are having that we are showing us that this one is representing the treatment, this one is representing the block, and the other one is representing the error. Are we going to use these formulas, or do we have to know the background of how to prove these formulas?
No, I don't think proving them it will be essential, but I will check with Mr. Malulaga. But proving it is not essential. But if you are going to prove it, this is how you're proving it. Do you see? This is how you prove it. But here I just wanted to show you that whenever there are many formulas, especially on the treatment and the blocks, sometimes they multiply it with beta. This is what I wanted to show you when I was projecting this. And again, there is a formula where we want to find the blocks. We multiply it with the treatment. But the one which you know is this ones. The ones which you know is this ones. Is this ones. Is this ones. Then it means here that is how it is. I was told that you know how to calculate this, you know how to calculate this, and you know how to calculate this. But there are many ways you can use this formula or these formulas where you find the mean. This is the mean of the treatment. Sorry, this is the mean of the treatment, and this is the mean of the block. Then you calculate, then you get the answer. Do you understand these two formulas? They're the same. They're just the same. But there are many ways to fry a dog. Which one is simple? But I think this one is simple.
Yeah, this one.
Yes, yes. Now, this ones I was told that this ones you know. That is that. Please, these formulas, we are going to use them in the afternoon. We are going to use them in the afternoon. May you please, they are there in the guide. Let me just check page 1. They're there in the guide, page 20 and 21. 20 and 21. Now, after doing that, after calculating all this, the same way when you were doing the CRD, you have to do what we call ANOVA table. But with the RBD, which is the randomized block design, we are having 3 things or 4 things. The first one, we are having the treatment, we are having the blocks, and we are having the errors. Remember, from this formula of the total, we had the treatment, we had the blocks, and we had the errors. That's why we had what the answer was total. Similarly, with this one is the 3, the treatment, the blocks, and also the errors. And this is under RBD. Where under, I will come to you. Oh yeah, just ask, because when you are raising, yes, ask Maluleke.
Hello, sir.
Yes.
What are we testing for in this case?
Now, what we are going to do right now, we are not yet started to test. Now it's just writing formulas, substituting formulas, but at the end, we want to do something which is coming now.
Okay,
The next
thank
slide.
you.
Yes, the next slide. Yes. Is it the next slide? Yes. Now, after doing all this, the ANOVA table, because even in CRD, you are doing ANOVA. Even here, you are doing ANOVA. But here it was one way. Here is what? Is 2-way. Why 2-way? Because we are having the treatment and the blocks. Why 1-way? Because we are only having what? The treatment. But here we are having the 2-way. That's why we are having the treatment and the blocks. Now, this is the formula for those. This is the formula, the SST which we managed to find here. Because these things we are going to do them in the afternoon. The MST, you know how to find the MST, which is the SST divided by the degrees of freedom. Then the F ratio, or the F test, or the test statistics of F, then is MST divided by the MSE. Similarly with blocks, whenever you want to find the SSB, then it will be the SSB, the one which you managed to find here. Then you put it there. Then the MSB, which is the mean sum square of blocks, you divide it by this, by the degrees of freedom, then you get this. Do you understand this table? Because we are going to use it at 3 o'clock. Do you understand this table? Ladies and gentlemen, remember me.
Yes.
I'm going to ask you, do you understand all the time? Do you understand all the time? Do you agree? Do you, so that we can have conversation? Now, somebody was asking me, what are we going to test? Yes, this is what we are going to test. Now we are going to test. Now the first one, we are going to test the treatment, the means of mean. It will be okay if I write TSSST. Simula, you see, we must have a common thing so that we may not struggle. But if you are writing a quiz, yes, you may do that. But let's say you write the test and I'm not available, somebody has to mark, and the memorandum says that, and they give you 0, or exam, you ask for remarking, and the memorandum says this, and you are writing that. But with the quiz, yeah, you can do that, because the quiz, I have to mark it no matter what or not, even if it waits for what December. Now we are going to test. Somebody was asking, what are we going to test? We are going to test the treatment and also the blocks. Remember, under CRD, you were only testing the treatment. You were saying this is the sum of the treatment is equals to 0. You are doing that under CRD. But now we are doing two things, 1 and 2, which we are going to test. We're going to test the mean of the treatment. Now, this is what we are going to test. Somebody was asking me, what are we going to test? The objective of the test, which is the null hypothesis. The null hypothesis is that there is no difference among the treatment means. There is no difference. The mean of somebody is raising the hand. Now, Mabunda, blessing, class rep. Is that you? Blessing. Yeah. Then you are disturbed me. Now we are testing the null hypothesis. We are saying no difference among the treatment means. That means we are saying under the means are of the treatment are the same, are just the same. And T1, T2, T3 until TT, until tau T is equals to 0. But the alternative says if you get 1, which is not, that differs. Then in order to test this, because we are testing two things. This is what we are going to do in the afternoon. We are testing two things. We are testing the treatment, which is the first one, which here, and also the test statistic is given by this, but you know these things. Then we also test. We want also interested in testing whether or not the variable that we have inserted inside to say it might be a factor. Is it advantageous? Is it advantageous? Does it bring effect when we have inserted that variable called block? That is the question. That is what we want to test. Now we test. We are saying I does not give us, is not effective. Whether one is equals to beta 1, beta 2, beta 1 is equals to beta 2, beta, all the betas are the same. There's no effect. But if we find at least one, that means there is an effect. Whatever we've inserted as a variable that we thought it might be it might be the variable. For example, personally, I love giving practical example. Let's say you ladies, yes, you have a certain man in your head that you want, and you got this one called whom should I use as an example? Man. Which one should I use as example? Let me use Mabunda. You have Mabunda now. Mabunda has married you. What is the factor? What was the factor What is it that made you to block other people? What made you to block other people to go with Mabunda? That is what we call blocking. That is what we call blocking. Does that factor that made you to marry Mabunda or Mabunda to marry you, is it effective? Was it effective? Or let's say, was it effective? Some of you are saying money is a blockade. I mean, ladies, money, tall, dark, and handsome. You are saying all these things. Guys, when it comes to guys, they will say, I want somebody, the blocking factor that made you to marry that woman. What it is that made you to block other people. Manyama, what do you think is a factor that blocks other ladies from the from the one that you're going to marry? Manyama,
Uh,
what is it?
on my side, I will say curves or beauty. The beauty
Oh
of
yeah,
the woman.
curves, beauty. Yes, you see, curves or beauty. If a person, that means for Manyama, it means the curves and the beauty have blocked everything. That is what we want to check. We want to check the effectiveness of that curves. Was the curves effective for blocking? That is what we want to check. This is what we are going to do in the afternoon. We are going to calculate this in the afternoon. Please. Then, how do we know that these things are effective? We conclude that blocking was effective. Let me show you. Where am I? Whenever, let me maximize this so that you may see it. We are saying blocking is effective whenever this calculated, which is the f calculated, is greater than the critical value. This is the critical value, meaning the value from the table. And let me go back a little bit. That means this one is numerator, this one is denominator. That means if you check this from the table, you know how to check it. You know how to check it. That is that. We are saying that blocking, that factor, that variable that we have inserted as modules or as curriculum, it has an effect on the salaries, on the salaries. Yes, on the salaries. Now let's continue. I think let me stop here under one, or let me continue, but we are going to do only module one. But let me continue because there's something which I want to rectify on somewhere. The pairwise comparison for treatments, they are done. We said, we are saying these are done if the ANOVA test on the fixed model concludes that the treatments are different. What do we mean? What do we mean? We mean that these are different. If we can conclude that this, then we perform the comparison. Do you understand, ladies and gentlemen? We only compare if this one holds. Do you agree? But if T1, you see, if we fail to reject this one, there is no need to do the comparison test because they are equal. Do you see, ladies and gentlemen?
Yes, sir.
Oh yes. Then this is the one we want to do. That tau, which is the mean and different mean, is the same. That is what we want to compare. We just want to compare that is this minus this. Is it 0? Sorry. Is it 0? That's what we want to compare. This, for an example, let's say this is y bar 1 and y bar 1 and y bar, let's say this is y bar 2. We want to see whether this are 0, check 2 and 3. You just check. You do comparison. Then this is the treatment. This is the comparison test. If we choose to use, which is the LSD, some they call it the minimum, some they call it MSD, but the formulas are the same. They are the same. It's just to say minimum, minimum or the least. It's just the same. That is, different books use different terms, but let's stick to this one, LSD. Yes, if we choose to use the least significant different method for making comparisons, then the least significant is given by this. All this, now the T from the table, yeah, this what I wanted to is here. This is bar, this is bar, must be bar. If you can even change it in the notes, in your notes, it must be in your guide. If you're having a guide, it must be yi dot bar minus y I, which is different from that, must be greater LSD. That is what I wanted to change for today's class, so that in the afternoon we can do those exercises. Now, this is what I wanted to rectify. Since I've done that, then we declare that the mean, the two means, which is mean 1 and mean 2, or mean 2, mean 3, are declared significant difference if this one and this one are greater than LSD. That means if you get the mean 1 of the treatment 1 and of the treatment 2, of treatment 1 and of treatment 2, are they greater than this, the absolute value? Absolute value means positive. Are they greater than the LSD? The mean 1 and mean 3, is it different? Is it greater than LSD? Mean of treatment 3 and mean of treatment 2, are they? That means if you're having 3 treatment, that means you will have one, let's say with 2, then you come back, you will have 2 with it can be with 3, you can have 1 with 3. Now all are absolute values. Now you have to check, is this answer greater than this, where this one you're going to get it from here. Then this one, please just read it. Just read it at the meantime. Then we'll do it. Where we do the random, under random effects, we check the variance. Any question, ladies and gentlemen, about the theory which I gave you today? Are you ready for the question?
Say we're ready for the questions.
Yeah, in the meantime, let me give you a question while you are going to relax. I prepared this. Can you take this one? You can take a picture. It's still fine. Then when you are done, yeah, let me first edit the slides. Then I will share the slides after maybe the afternoon class. What do you think, Siba? Yeah, because there is X bar, the Y bar that I need to fix. Go to slides model 2, okay? Yes. Yeah, I said you must read this. I will send the slides today, read them, and I'm tempted to do it tomorrow. Sorry, Friday, because Friday is just, and I will just give just a background because already you have done. If you can do the one in, so also RBD, we don't have the issue of balanced. Oh yes, we'll come to it because I explained. I said assume that there are numbers that are missing. That means the RBD is going to have a problem. Then if it's going to have a problem, then we'll come to what we call unbalanced. And under unbalanced is when we are going to include estimation. But that one we'll do it next week. For this week, I did not prepare that one, but that is the one for next week. Matume? Manya.
Yeah.
Yes.
I want to ask a question. Yeah, as the class rep. Say, I want to understand if maybe at least is it possible if you can continue teaching this module? We reserve Mr. Maluleke for practicals. Then yourself will continue with this module.
Practicals. Even myself, I must do practicals.
That's why I'm saying we reserve Maluleka for the practical. We'll take Maluleka to the practical, then the teaching is you.
No, it will be unfair. Yes, he has helped me a lot. It will be unfair. He has helped me a lot, and I must also help him because by I was supposed to start chapter 1, chapter 2, and chapter 3, and so forth. But he came to my rescue and he said he will do it for me because I was busy doing other things. Now, if we leave him outside, no. I disagree.
It's not, it's not like we are leaving him outside. Like looking at things, how they are going. This semester is so short to an extent that if we are going to have a lecture teaching us theory and at the same time thinking that we will have time for practicals, I don't think we are going to have enough time on the practicals.
I hear you, but the issue of practicals, is it can take only a day. It's not something that is huge because we run ANOVA is there. Maybe one day when I teach, I will include that small part of practical to show you that it's just clicky. You just click and click and play. You see, produce those things. I don't think it's too much. I don't think it's too much. We can do it here online, practical. No need to go to lab. Any question? Remember, I gave you homework to do the random effect. I will let you know if we can do it on Friday. Yeah, there is yes, there is a max. You must write the practical. They must write the practical test, the assignment or test. Yes, submit. You have to do it on. It's something that which is online. That's why we say practical. It's something that you do it online. We'll give you a data set. The same. Let me give you an example. We'll give you something like this. Something like this. Then we'll give you these questions. Then it will be your practical. Then, but this we wanted you to produce the ANOVA table from maybe from SPSS or Excel to produce the ANOVA table
Sir,
using yes.
sir, let me help this kid here who does not know, maybe understand what is the significance of us having practicals. They are needed when you try to apply for a job. Programming skills under analytics is needed, is required.
Oh, thank you very much. Thank you very much. Ladies and gentlemen, see you at 3 o'clock. Let's do this example. Let's do this example. Thank you very much.